So we're looking at graphing a hyperbola that is not centered at the origin. So how do we go about that? It's essentially the same process as before, only instead of using formulas for the asymptotes, we're going to create the box that we used in the previous problems, and that box is going to be from the center, which isn't at the origin. So if we have, we're looking at the form x minus h squared over a squared minus y minus k squared over b squared equals 1. The center is hk. So we're asked to graph x minus 3 squared over 25 minus y minus 1 squared over 9 equals 1. First off, notice because the x squared term comes first, it's the positive term, so that means it opens left to right. Its axis is horizontal. We know our center is at HK, which is, in this case, is going to be, it's at 3, 1. H is 3 because it's x minus h, and y minus k, k is 1. So the center is at 3, 1. We're not going to write down the center just yet, since we're not coming from the origin. We need to determine 25 is a fairly big value, so we're probably going to have to change our scale because of how big that term is. So let's look at a squared for our vertices. And this is from the center, 3, 1. We know that a squared equals 25, so a equals 5. So we're going to be going plus and minus 5 from the center. So we're probably going to want to go ahead and change our scale to 2 instead of 1 in the x direction. B squared equals 9, which means that b equals 3. So we're going to go those directions for those amounts from the center in order to find the vertices and make the box and then draw in the asymptotes. So our first vertex, our center is at 3, 1, so we'll go ahead and we'll graph that center. 3 is right about here. I think we'll be fine leaving the y scale at 1. So we'll go to 3, 1. There's our center. We want to go 5 to the right and 5 to the left. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then from the center, our center is at 3, 1. We want to go. So the points 5 left and right are at 8, 1. And the other vertex is going to be at 3 minus 5, which is going to be negative 2, 1. We'll go ahead and write that so our graph doesn't get too busy. 8, 1 and negative 2, 1 for our vertices. Go ahead and erase this all the labels off of the graph so it doesn't get too busy. I'll write them over here, 8, 1 and negative 2, 1. And if you want to do that algebraically, you can always just take the points and subtract. For a squared, it's going to be h minus a and k, and h plus a and k. In this case, that's 3 minus 5, 1, and 3 plus 5, 1, which would be 8, 1 and negative 2, 1.
So 1, 2, 3. 1, 2, 3. And for b squared, that's going to put us at h k minus b and h k plus b, which in this case b is 1. So our h is just going to be the same each time. 3. And then 1 minus 3 is negative 2. And 3, 1 plus 3 is 4. So now we draw in our box. It's going to look a little different than what you would expect because of the scale difference. Remember, in the x direction, it's technically twice as long as what it looks. To draw in our asymptotes, and then remember, because the x squared term is first, we know it opens left to right. So we start at our vertices and go infinitely towards those asymptotes, left and right. And if we wanted to cross our T's and dot our I's, we could look at the negative b over a is going to be negative 3 over 5. 1, 2, 3 up, and 1, 2, 3, 4, 5 over. So the slopes check out on our asymptotes, verifying that this is the correct graph for the hyperbola represented by x minus 3 squared divided by 25 minus y minus 1 squared over 9 equals 1.